multiplied by minus y now, right, over IZZ. So when that is the case, the outcome from here is this whole equation over here, minus times minus will be what? Positive. So that is why we have what? Tensile. Okay, so that is why any textbooks that you see, it will highly enforce on this negative sign. But there's another way that we can view this, okay? And this is the way that I've developed based on a lot of examples that I've done. So if we look at the moment, right? The moment arrow will always point in this direction. Okay, to induce a deformation that way. And if that's the case, when you know the rate moment arrow, the head of the arrow, so this is the head, and this is the tail. The head of the arrow will always be in compression. The tail of the arrow will always be in tensile. Likewise, for the other side, the head of the arrow will be in compression, and the tail of the arrow will be in tensile. Right. So now, if the structure now, okay, if I'm going to reverse it now. Okay, if I'm going to reverse this now. So I'm going to reverse the structure now. If our deformation gone this way now. Okay, so this is how our structure is deformed. Right. And then this is our neutral axis. So the points alpha and beta is still the same. Location wise, did not change. So again, this is my point A. This is my point B. And this is my point C. Right? So now, can anyone tell me, okay, where is Y positive now? Is it the same as the one above, or is it going to be different? Anyone, please.
It should be the opposite now, right?
Yep. So you're right. So now, over here, you're absolutely right. So over here, now, this is the center of what? Of curvature now. That is where your center of curvature. So when that's the case, right, anything pointing towards the center of curvature, Y is now positive, pointing away from the or from the neutral axis, going away from the center of curvature. Now Y is your what? Negative. Okay, so likewise, you can see over here what you have now is stress X. Okay, so now we want to find stress X at point alpha, and now we also know that now Y is also equal to negative. So therefore, your stress X at point alpha is equal to, using the fixed formula, minus mz over izz. Now this will become what? Negative Y. So that's where this over here will be positive. So now this is what? In tensile. Likewise, I will do the same for point X beta. Now it comes that Y is going to be positive. So therefore, stress X beta is equal to minus mz over izz multiplied by positive Y. So this will be equal to negative. So this is in compression. Okay. So if I'm going to apply what I've written earlier, so based on how the structure is deformed, the moment is acting in this direction. Okay, the moment is acting in this direction now. Again, the head of the arrow is in compression of the moment arrow, and the tail is going to be tensile. It still works. Okay. Right. So I hope that you are clear now why the elaboration is on the minus sign over here.
Excuse me.
Okay. Yes.
Could you explain again how you knew whether y was positive or negative, please?
So yes. So the question is, how do I know whether is it y positive? It all depends on where the center of curvature is. The center of the curvature is where the reference is. Okay. So when at beta from the neutral axis is pointing towards the center of curvature, that's where y is positive. If you look at the other way, right? So the center of curvature is at the top, right? So from the neutral axis, and alpha is above the neutral axis towards the center of curvature, that's where y is positive. Does that make sense now?
Yes, thank you.
Right? So it's all dependent on the center of curvature. Okay. Now, any other questions, please? No? Okay. So now, the critical thing is this, okay? Sometimes we tend to forget what is positive, whether the formula is positive or negative, okay? So I don't want you all to worry about whether is it positive or negative. I want you all to observe based on deformation, okay? Or based on the moment, especially what I've taught down here about head of the arrow and tail of the arrow in the moment vector. So at the head of the arrow is always compression, at the tail is always tensile. Okay, so you don't need to memorize positive or negative. Just by visual observation based on the deformation, you can know also. Okay, that's the best way to do it. I don't want you to like memorize. Oh, it's minus pointing to the center of curve. No. Okay, look at how the structure deform, and then you decide. As engineers, we need to visualize. And as mechanical engineers, we can see, we can visualize. Okay. So the next thing that I like to elaborate is what is this stress that we are calculating? Okay, what is this stress that we are calculating? So what is the stress, or what, or where is the orientation of the stress that that is calculated? Okay, so if I were to look at this figure again, okay, I'm going to copy the whole thing. Don't have a lot of room. It's okay. Okay, so this is our structure. Then if I were to take an element, okay, so I'll call this my element at point B. Okay, so again, this is our X, this is our Y, this is rotation about Z. So if we look at our element, if I blow it out, if we look at our element, the element should be a square in shape. I do apologize. I think my daughter is yelling. Okay. So what we are calculating is the normal stress in the X direction. So this is the normal stress in the X direction. Okay. So that's where we have this expression where I wrote stress X is equal to minus mz over izz multiplied by y. Okay, so that is the direction of the stress that we're calculating. So if we were to look at our problem set over here, okay, if we were to look at our problem set over here, and then we were to construct our neutral axis, right? So if our structure has a cross-sectional view like this, so this is our cross-sectional view now. Okay, so this is a cross-sectional view. Okay, if that's our cross-sectional view, I'm going to the next page. So this is our cross-sectional view. And then I'm going to draw it bigger now. Okay, so this is cross-sectional view. And this is at, so the top point, right? So sorry about top point. Then we know that this is our neutral axis. Sorry, our ZZ axis. And our ZZ axis is also the location of the neutral axis. And just to help you quickly recap, okay, the neutral axis is where your stress in the x direction is equal to what? 0. So now if I were to sketch our profile, okay, so I will put where our load is. So our load is applied at the top. Okay, so this is our P. Okay, so you all can visualize. So if I were to draw our orientation, so this is your Y now. This is your Y. This is your Z. Okay, and then your X is coming towards you. So this is your rotation about your X. So I'm going to sketch a diagram now. Okay. So over here, this is your normal stress in the X direction, and this is your Y. Okay. So on the right hand side, it is all in the tensile mode. On the left hand side is on your compression mode. Okay, and this is your the limits of your cross section. Okay, so the limits, because why I take that limit, so if you were to draw the line, those are the upper limit geometrically, and this is the bottom limit. So we know that the top is going to be in compression. Okay, if the P is at the top, so we know that this is one of your point, and then you draw it across. So this is your stress profile, right? So this is going to be your stress profile. Right, where the top, where this point over here, this is equal to minus, or this is your negative my over I, and over here, this is your positive my over I. Okay, so when we were to construct your arrow, we're going to draw the arrow this way, okay, on your stress profile. So you've seen different textbooks do different stuff, but I hope you all adapt. So if it's compression, so we have to imagine this is the location of the material. The straight line, the y-axis is location of material. Okay. When it's compression, it means that if we are pushing towards the y-axis, right? Compress. Because your y-axis, so I'm going to write down here, your y-axis is the location of the material. Then at the bottom, is going to tensile, so it's pushing away, right? So from the material, it's pulling away. This is in tensile. So this is how you draw your stress profile of the cross-sectional view in the x direction. Okay, and what you can see over here at the neutral axis, right? So this is the location of the neutral axis. We realize that stress x is also equal to 0.